Okay, I've started recording, and so handing over to you, Padma, to do the introductions and to get started.
Thank you, Susan. Good morning, good afternoon, and good evening, everyone. Happy New Year. And this session is 1st of May in 2018. Let me introduce our distinguished guest, DanielPakkala, who is a principal scientist at the VTT Technical Research Center of Finland. He's focusing on data-driven solutions for intelligent industry applications. He's currently also IBM's Distinguished Visiting Professor at IBM Research Almaden, cooperating on R&D of open artificial intelligence technology. So the title of the presentation today is, I'm hearing a lot of background noise, Susan. Somebody's typing?
Yes, could you please all go on mute immediately? I'm going to start muting people as well, but please all go on mute.
Sorry, folks. So let me start again. The title of the presentation today is Opentech AI Architecture, Ecosystem, and Roadmap: Drafting the Big Picture and Future Directions of Open Artificial Intelligence Technology. So that said, Daniel, take the stage away. Thank you so much for joining us.
Thank you, Padman. Thank you, Susan. I hope you're hearing me well. And good morning, day and evening to everyone, depending where you are. Today, it's beautiful morning here in California. So yes, my title today is Opentech AI Architecture, Ecosystem, and Roadmap. And as you can see, the scope is quite wide, and there's lots to discuss about this topic. But I hope that today I can provide a sort of outline and frame what we are doing, and point you to also the direction that we are going towards. And this is work in progress in cooperation between VTT and IBM Research. And right in the beginning, I would like to also thank my co-operator and mentor on this topic, Jim Sporer. And let's have a second slide to go to the outline. So I'm first going to give you a short introduction and background to this work, followed by our journey on drafting the big picture of AI, touching the topics of is AI more than machine learning and deep learning. Then I will say a few words about AI amongst the sciences, and also talk a little bit about AI systems today and what they might look like in the future. So then I'm also going to shortly show you one view or a big picture of AI that we have come up with, which is of course not the only one, but at least it's one effort to try to frame the topic. And from there, I'm going to frame the discussion and topic towards architecture framework for AI systems, and finally say some words about catalyzing and measuring progress of AI. Next slide, please. Yeah, as a context for this work, I arrived here in San Jose, Almaden last August to cooperate with IBM and Jim Sporer on the topic of Opentech AI. And we have co-created a blog mentioned here, which all of you are welcome to check out. And within this area of Opentech AI, we are covering topics such as architecture, ecosystem and learning, process and tools, platforms and technologies, progress and roadmap, applications and impacts. And this presentation is mostly focused on the topic of architecture and the progress on that thread. So in the blog, we have resource pages for each of these topics, so you're welcome to check those out there. And also for everything that I'm going to describe today, there will be more information available in the blog as well. Next slide, please. can we have the next slide, please? Thank you. So first, let's discuss shortly what we mean by Opentech AI. Can we go one slide back, slide number 4? Susan, can we have slide number 4?
That's what I think I'm showing.
Ah, okay, thank you. Now it's showing.
Do you see it?
Yeah, now I see it.
Okay, good.
Thank you. So, so Opentech AI, what we mean by this, of course, the first association comes to open source software, and that's of course one of the core things, open source software regarding the tools and platforms and code related to AI, R&D and development especially, but also referring to open datasets, open models, open AI challenges and leaderboards. And so why this is important, the way at least I see it, is that from this viewpoint of science, it's very important to be able to reproduce the result in order to have real progress on topics, and this open approach to AI is certainly beneficial for reproducibility of the results. And from the industry viewpoint, it's also important for having the actual impact of AI via AI applications and development. Next slide, please. So today, AI R&D is mostly focused around machine learning and deep learning, and narrow AI applications are reaching or outperforming human capabilities in this task, like Jeopardy in 2011, Go in 2016, and reading comprehension, or rather searching Wikipedia for answer, earlier this year in form of squad leaderboard. Then we might ask ourselves a question, what more is needed? So the way I see it, at least, is that we are mostly dealing with closed world problems and closed world assumption in the current systems, and we are moving towards open world problems in the future systems, meaning that these systems should have some sort of common sense knowledge and reasoning capabilities. They should have some kind of word model. They should be able to learn concepts in addition to just categorizing and mapping. They also should have multiple or adaptive learning strategies, and of course be context-aware, adaptive, and able to naturally interact with users or humans. Next slide, please. So when we started this work, we read a huge amount of publications related to AI, and the first thing I noticed is that the field is very interdisciplinary, and sort of after a while, myself at least, I was a bit lost in this jungle of sciences, and so that for that reason I drew for myself at least this kind of mind map that is shown here in this figure about the relations of AI and how I see AI and what are the related sciences. So my view to the topic is that in the core we have, from the systems perspective, system science, computer science, and mathematics, surrounded by cognitive science, biology, physics, and social science. And here I have also characterized some of the interfaces between AI and cognitive science. For example, is mainly about AI implementing the cognitive architectures within intelligent agents, multi-agent systems, and other intelligent systems for various applications. But then also related to this, AI is influenced directly by neuroscience, for example, in form of artificial neurons and artificial neural networks. And on the natural language processing front, there's of course influence directly also outside the complete cognitive architectures, for example, in form of word vectors nowadays. The interface between AI AI and biology, on the other hand, intelligence is a natural and biological phenomena which AI aims to mimic, and also the potential new findings related to evolution, cells, neurons, and brain are also have potential influence on AI R&D as well. So the interface between AI and physics then, well, as for any artifact, availability and applicability of physical materials and energy for building and operating systems is a limitation for AI systems as well. And on the other hand, also physical environment and the physical laws are highly relevant for AI applications that are intended to operate in the physical world instead of the cyber world only. Finally, the interface between AI and social science is mostly characterized by the acceptance, impact, need, and use of AI applications by individuals and organizations. And after all, the value of the AI applications is defined by humans and human organizations in social context. Next slide, please. So, what were the takeaways or learnings from this visit to this AI-related sciences jungle? First of all, the progress of AI exploitation is dependent on the progress of R&D on the related fields, which are all still active fields of research with potential new discoveries. And on the other hand, it seems that there's multiple parallel tracks of AI research and development proceeding in parallel, which are not necessarily mutually interoperable from the viewpoint of building new AI systems and applications. For example, regarding machine learning and deep learning and artificial neural networks, there's at least around 25 different types of artificial neural networks currently known. On the other hand, on the side of cognitive science, according to recent study, there's nearly 100 cognitive architectures, of which about 50 are still in active development. And both of these categories have different kind of approaches, ranging from sub-symbolic approaches to fully symbolic approaches, and also having hybrid approaches. So what does this mean from the viewpoint of, let's say, complexity of designing AI systems? If we have 49 architectures and 25 different ways, at least 25 different ways to implement each architecture, we arrive at complexity of 10 to the power of 42, which is already a quite wide space of selections. So next slide, please. So today, AI systems are mainly seen as evolution of smart features of existing, enabled by machine learning, increasing computing power and availability of data. On the other hand, looking at the publications and visions proposed in those, the AI systems envisioned in future might be quite different kind of systems, autonomously maintaining themselves, operating, learning and interacting over extended periods of time as part of society, culture and natural environment. For example, one of the vision of software social organisms presented by the Ken Forbus in the paper mentioned here. Well, if the current outlook is the complexity space of 10 power to 42, with the kind of vision that having these systems to be a part of the natural environment and our culture, we arrive to close in the complexity that is close to infinity. So that's also something that is quite interesting from the viewpoint of designing systems. So next slide, please. So this was our first effort to frame the big picture of AI into some kind of one picture or figure presentation. We sketched this what we called AI cube, where we tried to frame the evolution of AI in 3 different dimensions, and in the context of evolution of natural intelligence and environment. I'm not going into details in this. You're welcome to check out more information from the blog site regarding this. But let's go to the next slide. So as a summary, so far, I think the transition from current AI systems towards the future AI system deserves a special attention from the viewpoint of systems architecture, especially regarding complex and autonomic behavior of a system, which is related to safety, security, trust, governance, and institutional control of these systems. Incremental learning and adaptive behavior, which is related to learning from data and the past interactions, and also capabilities and knowledge contained by the system. System lifecycle and maintainability, which are related to applicable methodologies and processes and how to ensure quality of these systems. Then also social, cultural, ethical, and environmental compliance, which is especially related to acceptance and value that these AI systems provide in the future. And finally, also interaction is a point of attention in a way that future AI systems might be a bit different to interact with compared to the systems that we are used to dealing with today. So here I have also mentioned a couple of good papers on this topic. And first one is the review of cognitive architectures from the past 40 years, presenting comprehensive view on different developments on this front, and which we have been also studying and taking into account in our work. And another one which is also going towards kind of harmonization of the field is the standard model of the mind paper by Laird and company, which is titled Toward a Common Computational Framework Across Artificial Intelligence. Also in this topic you can see more information on the blog site. Next slide, please. So we also have outlined a first draft, if you would like to say it in this way, about how to approach the AI systems of the future, from the system architecture viewpoint. So here in the figure we have presented AI systems in the middle, covered by 4 different types of stakeholders. First one on the left being AI research and development community producing the AI related knowledge and assets, which are then usually taken by the AI system stakeholders producing the actual systems, presented on the lower part of the figure, for the actual users, or what they call AI collaborators, to use and get the value of the systems. But as a fourth stakeholder, we have also included environment, especially from the viewpoint of environment and social responsibility, enabling to address these kind of requirements in the system lifecycle as well. We have also, as in this first version, tried to kind of identify the basic subsystems in order to break down the huge complexity into big smaller parts that would be easier to approach as an individual subsystem. So these presented here are embodiment system, being the physical material structure enabling implementation of other subsystems and bounding interface with the natural environment. Then perception and actuation, including all the mechanisms related to the sensing and actuation of the system with the environment. The memory subsystem, including all the different memory mechanisms. Behavior subsystem, including all the behavior related mechanisms, and cognition, including all higher cognition related mechanisms accumulating the internal word model of the system and possibly adapting the behavior of the AI system over time. And then as an orthogonical subsystems to this all, in a way, internal world model, which is basically the natural environment and the world as the AI system comprehends it internally, so containing all the knowledge of the AI system as a result of training and learning while in operation. And finally, internal data processing, which is the internal continuous data processing and analysis pipeline of the AI system, defining the mechanism for converting the data flow from perception subsystem to information, knowledge, and wisdom as modifications of the internal word model and behavior. So it's important to notice that we are not proposing any kind of specific contents for these boxes, but we are trying to just identify a framework for analyzing and going forward in this topic of trying to see the architecture framework for AI systems according to definitions of ISO, IAC, IEEE 42010. So that's the direction that we are currently trying to go in the architecture work. And this approach could be characterized as a hybrid model-driven approach combining agent orientation and holistic two-dimensional system orientation, where system thinking is applied both to the external environment and to the internal organization of the AI system. Next slide, please. Yes, a few words about catalyzing and measuring progress of AI. Regarding this architecture framework, I see that it could have benefits for the community in form of breaking down the complexity involved in this design and engineering of AI systems. It also could provide an analysis and design framework for these kind of systems, and it could also enable hybrid and mash-up approaches in application development when identifying synergies between different AI systems becomes easier. So regarding measuring progress of AI, we have a list of AI challenges and leaderboards on our blog site, and I welcome you to check those out. They are categorized according to different capabilities of the AI systems, and in addition to this, which are mostly today kind of task-specific challenges trying to match human performance in a certain task, we would like to also investigate a more holistic view on AI progress and measure performance also in terms of, for example, energy, and trying to match, for example, also in energy the human performance. So basically not just measuring the task outcome performance, but also taking into account how much energy did this task consume. For example, the current estimate of brain simulation with current supercomputers would take around 20 gigawatts of energy, which is multiple nuclear power plants, whereas the human brain only takes about 20 watts of energy or power. So there's a challenge on that front as well, which is of course currently addressed also by development in computer architectures in form of quantum computing, neuromorphic computing, and optical computing, for example. So our proposal here would be that it would be also nice to address these metrics a bit more holistically, taking into account other aspects than the task performance itself. Next slide, please. Yeah, this was all that I had on the architecture. The figure here tries to explain the other task that I have at my hand. So to balance this quite abstract work on the architecture, I have been also developing a TensorFlow-based model for predicting energy consumption of a house as a function of previous power usage and weather forecast. So that's just a balance of this kind of abstract work that otherwise I'm doing currently. So are there any questions or comments?
So I see a question in the chat. Will there be another AI winter? Reasoning will be hard. And there's another question, how does quantum computing affect that energy model? So a couple of questions there.
Yeah, so predicting AI winter is quite hard one to answer. So I start from quantum computing. So I certainly see quantum computing as a way to address this gap of energy consumption between current AI systems and human brain energy consumption. So certainly I see it as an important step when going towards more intelligent systems and more computing power needed behind those. So for AI winter, I hesitate to say anything, but maybe I say it in a way that it would be important for the community to be able to provide tools for making AI applications and impact, sort of harmonize the field to make it easier to develop the actual application, and this might also be one way to avoid the AI winter.
Any more questions for Daniel? Let's have a look and see in the chat if there's anything else. How does quantum computing affect the energy model? Somebody's asked. I think there was a long conversation in the chat about that. Anyway, so what I'm doing now, or waiting for more questions. Oh, somebody says relatively little on ethics, but I'm guessing ethics, we'll have sessions on ethics as well. But do you have any remarks, Daniel, on ethics?
Yes, I have. I didn't cover it very much in this presentation, but I have some ideas related to that in my blog article. So please, I refer to check those out.
Excellent. Okay, so you could put a link to your blog maybe in the chat. Can you see the chat, Daniel?
Yes, I can see it.
Yeah, that would be good. And somebody is suggesting that your slide 6 should refer to ethics.
Okay.
So you're getting feedback from the audience.
Thank you.
And yeah, we're getting, yeah, I'll keep the chat open for a while, but I'll stop recording. But if people want to continue to chat, please go ahead. Also, I've posted up here the series. So our next talk will be on Feb 22nd, unless we have somebody sooner. If somebody wants to speak on the upcoming Thursdays before the 22nd, but on the 22nd we'll have blockchain and artificial intelligence. Daniel, did you want to say anything about the event in Helsinki or no?
Yeah, I might mention that we are having a Opentech AI workshop upcoming in Helsinki in March. So you'll find more information on that topic from our blog site as well, and you're welcome to check it out and participate if you are.
Yeah,
interested.
so I'm sharing some information here. I can post the link if people are interested in the upcoming workshop in Helsinki. There's a registration link. There's more information. I'll put that here. Okay, I'm just adding that to the chat. Anything else, anybody, before we close? Nope. Okay. Well, thank you. Thank you so much. I'll leave the chat open as I mentioned. I'm going to stop recording.